origin, you knew where that one went, right? Where should the origin go?
In the middle.
Right in the center. So that origin 0, 0 would go right in the center. And I was going to ask you guys to come up and do graphing, but sometimes the board's a little bit off and it's kind of hard to tell where that's supposed to be. So that'd be the origin there in the center. Now point P, do you guys remember what the 3, -2, what's it telling us to do when it says 3, -2? Like what ways are we supposed to be going? Yeah, Reagan?
You're supposed to 3 over and then 2 down.
3 over which way? To the right, yep. So it's going to be right 3, down 2. So when we do this, it's left and right first, and then up or down. So when you see your coordinate points, so like for an X and Y, it's always left and right, and then up or down. Positive, negative, depending on left or right, or up or down. So for point P, I'm going to go right 3 from the origin and then down 2. And you count lines, not blocks. Like sometimes it's kind of confusing. I guess you can count blocks, but it might be easier to count the lines, or I guess I don't know which is easiest. So, so there's point P. So for Q there, tell me how to move. How do we move for Q? Yeah.
Since it's negative, you move left, 4 to the left.
Yes. So left 4 and then,
You don't go anywhere, you just stay the same.
yeah, so don't, not up or down at all, but just stay. Now, when we have a new coordinate point, we go back to the origin again. So we go back to the origin, go left 4, and then we don't move up or down at all. So there's our point Q. Which one's the y-axis?
The one arrow that's going up.
The one arrow that's like, yeah, the up and down arrow is the y-axis, so this is like the vertical line. So this one's the y. So the y-axis is that one. Whereas the x-axis then obviously is the other one, so it's the left or right one. Oops, what did I just do? Did some sort of magic that I didn't plan on. Go there. Now the quadrants, you guys, I will be perfectly honest, I'm looking at my notes from last year and I labeled them wrong last year and I probably had to go back and fix it with them. I mess this up all the time because it's just not something, like I get there's times where you're like, why do we ever need to know this? Quadrants are probably one of those things, unless you're in a math class, it's a really weird thing to have to know. A quadrant is, like I said, I forget them from time to time. And I was looking at my notes because I was like, I feel like that's wrong, and it was. So the big thing is the first quadrant is this one. That's kind of where everything starts from. However, the second quadrant, for whatever reason, I messed this up too. It actually goes counterclockwise. I actually opened our book to make sure I was right on that. So quadrant 2 would be over here. So anything in that quadrant would be considered in quadrant 2. We go counterclockwise, and then this is 3, and then this is 4. And there's reasons why they go counterclockwise, but like I said, I forget it all the time if I'm not in that unit. So if you wrote that down wrong, totally understandable. Like I said, I looked back at my notes from last year and I was like, this does not look right. So they ask us to add these following points, so A, B, C, and D. So putting those points on the graph, and then writing which quadrant or which axis they're on. So if it's right on an axis, like point Q would be on the x-axis, we'd say that. It's not in a quadrant then, it's kind of on the boundary line. So if you guys want to take a minute to add those other points, if you haven't already, you might have to change what quadrant they're in if you have that written down wrong. Yeah. It was mostly 1. Which quadrant is negative 2, 1 going to be in? In quadrant 2. So negative 2, once I go left 2 and then up 1. So here's my point A. It's in quadrant 2. It's kind of a good quick check. Like if you're looking and you're like, oh, I'm in the wrong quadrant, just tell you moved the wrong direction. B is in which quadrant? In quadrant 3, the 2 negatives. So negative 6, and then negative 5. So there's B. C is where? On what?
On the y-axis.
It's on the y-axis. So you don't go left or right at all. You just go down 7. So here's C, so that's going to be on the y-axis. And then D is 4, 8, so that's in quadrant 1. So over 4 and then up 8. Now, those of you guys who like are just so you know, we're graphing today, and those of you guys online, I will post graph paper, and I'll give you guys graph paper when we do graphing. It's a lot easier than trying to draw these out. I mean, I know that when I freehand a graph, it looks pretty bad. Like we're going to do some whiteboards with the graphs, and you're probably going to be like, this is not good. But so know that I'll always give you guys graph paper. But if you're ever at home and you don't have it, don't like not do your homework because you don't have graph paper. So just that you know that I'm not going to be like super picky about that, but I'll always provide it for you guys as well. And there will always be graph paper posted like on Schoology. So if you have a printer and are able to print it, otherwise maybe even have a notebook of graph paper. Maybe that's just my house because I'm a math teacher, but we have graph paper at our house. So dorky math teacher problems with poor kids. So we're going to talk about graphing more today. Domain and range is something we talk about, but it's one of those things, again, it's one of those things you're going to forget when you're not in like the graphing unit. Domain is basically the possible x values we can use. So the x values that make sense for the problem. And then what do you think the range is then based off of that? The possible y values. Now where this comes into play probably most often is kind of when we're setting up a graph or if we're doing a word problem. If I say, we're doing a word problem and I'm talking about how many hours you slept last night. I would say, what possible values should we talk about in terms of the number of hours you slept? Would it make sense to talk about negative hours? No, so that wouldn't be part of the domain because negative hours, I don't even know how that would work. I don't know how you sleep negative hours. Like, now you could say I didn't sleep at all, so we could start at 0. But then something over like 24 doesn't really make sense. I mean, some of you guys will probably tell me, once I slept, how many hours, whatever it happens to be. But there's a limit to how many hours we can actually sleep in a row. So there would be a range of values that make sense. So like, for example, that, could be like 0 hours to, 10 hours, let's say, last night. I don't know how you can sleep much more than that in a given night, but unless you're really sick or something. So 0 hours to 10 hours, it makes sense for how much sleep you got. Then maybe like going off of that, based off the number of hours you sleep, maybe you could argue that it's how you're going to do on your test, like yesterday. So based off of how many hours you slept, let's compare that to your test scores. Maybe if you slept more, you got a better test grade, or maybe you stayed up late studying, so you didn't sleep as much, but your test went better. So then the possible y values that come from that maybe are your test scores. So like a 0% all the way up to 100%. Does that impact, we can kind of look and see, does the number of hours you slept, does that help your test grade? I was always wanting, like college, I didn't think staying up late studying was better. I was better if I got enough sleep. So like I was like more level-headed, because if I don't sleep enough, I'm kind of a cranky, like disoriented person. So sleep is important to me in terms of my understanding. So that's one thing that I like have a testimony to, is I think sleep is important there. So I would do, the more I slept, the better my test grade probably would have been. So that's what we're talking about, domain and range. What values make sense for the problem? Now, most problems we're going to do, the domain and range really can be anything. We could have positive, negative, zeros. It doesn't really matter. Now, this first one, they give us this domain. So they're giving us the x values. They're giving us the x values to use. Now, I think a great way to organize this would be a table of values. It's just kind of a way to keep things organized, so I'm not trying to like remember which with what. And so I'm going to put these values in as my x values. So they're giving those values to me to use. They say to find the range then. So if those are my x values, how do I find the range? What are we going to do? Those are the x values. How do we find the range? The range is the y. So what are we going to do? There's another part of this problem we haven't used yet. What are we going to do, you guys? Yeah. What's it?
Or the y equals 1/2.
Yeah.
Start on
Well, that's if you were just graphing. We'll get to what you're saying. That's not wrong, but if you're just trying to graph it. But kind of using these x values. So kind of hang on to that thought for a couple of sections. We'll get to what you're saying in a little bit here. What about these are my x values? How do I find the y values? It has to do with what she was talking about. Yeah, what do you think, Lucas?
You replace those values with the x in the equation.
Yeah, so we're going to put x into this equation to find our y. So we're going to have to substitute that x value basically 5 different times and find the y value that goes with it. So I'm going to do that work. Now, the fraction might already be kind of freaking you out there. Don't let that bother you. It's a half. It's not a terrible fraction. So we're going to substitute like that -8 in and figure out what our y is going to be. So we're going to put that in and do like the math with it. We're going to multiply and then subtract. And if you need a calculator, you're welcome to. Half of -8 though is -4. Then -3 is going to be -7. Make sure you're taking notes with us, guys, because remember we do notes quizzes. I don't want you to forget this stuff. So I'll also help you with your homework. And then we just have to keep replacing that. So half of -4 is a -2 minus 3, -5. Half of 0 is just 0, minus 3 is -3. Half of 2 is 1, minus 3 is -2. Half of 6 is 3, minus 3 is 0. So we found the range based off of our domain. So the range then would be all these y values. So in this case, the range would be -7, -5, -3, -2, 0. So it's just a fancy way to say what are the y values. Now I have this graph paper. If I have an x and y as a pair, I have a bunch of coordinate points. I actually have 5 coordinate points that I can just write on my graph now. These I can just write as a coordinate point and put those on my graph. So I'm going to take them from my table and transfer them over and graph them. So I have to graph a -8, -7. So that's my x and my y. So -8, -7. I'm going to give you guys a clue. These are all going to be straight lines. So if they don't form a straight line, careful. So, careful. -8 and -7. I think you should be going down. No, it's okay. Yeah, making sure you're in the right quadrant. You should start in quadrant 3. Usually something other kind of wonky happens if you're not in that right quadrant. So hopefully yours looks like a straight line. If not, something went wrong with one of your points. So check your points again if you didn't get them in a straight line. It's kind of a good way to know you're on the right track. And then in this case, we do get to connect the dots. So I'm going to draw a straight line through those. And I'm going to draw an arrow on each end. All right, we're actually going to grab whiteboards before we move on to the next thing we're going to do. The next thing is a little bit more open than this, so I want to make sure we're okay with this. So if this half of the room wants to grab whiteboards, markers, erasers, or Kleenex, or whatever is back there. Yeah. What's that? Yeah, go ahead. I don't need something like really elaborate. We're going to make kind of a small little graph just to practice plotting a few points, make sure we're okay with those. So just like 4 lines, or if you go a little bit more, that's fine. You don't have to do like 10 and 10 every way. I'm gonna grab a whiteboard. So what I'll do is I'll ask you guys to graph a few just to make sure that we kind of have the idea of the graphing down. I know we can make mistakes on it, but let's try to get it in the right spot and see how that goes. Again, I'll try to keep our numbers under 4, so that way you don't have to go too big or too huge. So you guys could graph 2, -4. And then you, like when you hold it up, just make sure you have it like upright the right way. Like if you have it all turned sideways, I won't be able to know. Yeah, so Haley, you're good. Yep, you're good. Yeah, good work. Good work. Good work. Good job. Yes, you're good. Yes, yes. Yep, and you don't have to erase your whole graph. Yep, yep. You can just like draw. Yep, you're good. You can, yep, yep. You can just kind of like make a little, quick little finger smudge, and you should be able to get it. You're good. So 2, -4. You got room for you. You got it. Good work. All right. So 2, -4. That means I'm going to the right 2 and then down 4. So right 2, down 4, here we are. So there's our location for our 2, -4. All right, let's do, so -1, 3. -1, 3. Good, good, good. -1, 3, yes, good job. Yes, such confidence. Yes, you're good. Yep. No, not quite. You're left and right first. Yep, yep. And I know it's totally easy to get them flipped. Yes, yes. You're good. What? Yeah. Yes. That is up. Yeah. Yes. 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 Good job. It almost looks like you have like a spot already there for it. Yes. All right. So this time, you guys, remember it goes left to right first. So I'm going left 1. So left 1 and then up 3. So left 1 and up 3. So it's our location. All right, these ones are always tougher, I think. 0, -2. So 0, -2. Careful, you're good. Yep. Yes. Yes. This one can be fixed with a board switch if you're wrong. 0, -2. Nope. Yes. Yes, yes. Good work, guys. Yes, good job. You can be like, just kidding, I'm holding my board in the wrong spot. But careful, so left or right, don't go at all. So just go down. No, it's okay. That's, yep. 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 There you go. Oh my God, it's hot. All right, so this time, you guys, the 0 says don't go left or right at all. So left and right, we don't move at all. This one tells us to go down 2. So we just go straight down 2 and then we're stuck there. Okay? So we'll go away from the graphs here for a little bit. It looks like you guys got that down. The next ones I don't need you guys to graph. We're just going to work on the table. So what I'm going to do is I'm going to give you guys an equation and you're going to have to find the table that goes with it. Or like I'll give you half of the table. So So I'm giving you this table, and I want you to fill it in based off of that equation. If you need a calculator, go ahead and grab one. So I'm going to be looking at the second half of your table, the coordinates that go with it. We're good. Good job. Great. Good job. Where are you dividing somewhere? So you're putting it in for the x value. So you're putting it right here. So 3 times negative 1. Good, you're good. You're trying to fill in these values for your x value. Find the y value. You don't need to graph this one. So, no, you're good. Okay. Good job. Kylie, you're good. Yes, good job. Yes, good job. Yes. Yes. Putting those in for x. Put that, whatever that is, to the y. Okay, see everyone's over here. Good work. Yeah. Does that make sense now? Were you putting it in the other one? Oh yeah, I was like, how'd you get the decimal? I think you just did this one, the math wrong, I think. Otherwise, all the rest of them are good. So guys, as we do this, we're putting these in for the x values. So y equals 3 times negative 1 minus 5. Now, since we start negative, that's always usually the toughest one. So just that you guys know, if that one threw you off, that's okay. It's usually the toughest one. 3 times a negative 1 is a negative 3. Minus 5 gives me a negative 8. Do the same thing with 0. Putting those in, you just kind of keep resubstituting that in. So 3 times 0 is 0, minus 5 is negative 5. And then they kind of start to get easier because the numbers get nicer here. So 6 minus 5 is 1. And then 12 minus 5 ends up being 7. And now we would be able to graph that if we had graph paper handy, but trying to get all these on a graph and then expect you guys to try and draw a straight line with that, it's a little bit of a mess. So let's actually leave the same table. I'm just going to change the equation. Oh, geez. I went too crazy with my... Aha, there we go. All right, let's try just changing up our equation here a little bit. So I'm kind of rearranging the order here a little. Trying to fill in the second half of that table. Fill your table. Got it. You're good. Good job. Good job, Reed. I think your first one is not right. Check that one again. Careful, because it's at the end that you're putting that in. I think your first one is not right. Check that one again. Yes. Your first one is not right. Yep, good job. I see yours already, you're good. You good? Yeah, good job. All right, guys, so on these, what we're doing again is we're putting those values in. Now, this one isn't as bad because when you start off negative, when you put 8 minus 2 times a negative 1, 2 times a negative 1 ends up being a positive 2. So this is 8 plus 2. So we get 10 here. So if you guys ended up with a negative at the start, just be careful with that. Then we have 8 minus 2 times 0. This goes away, so we just have 8. Then we have 8 minus 2 times 2. Remember, you have to do ordered operations, so you have to multiply before you add. So 8 minus 4, so 4. And then we have 8 minus 2 times 4, so 8 minus 8, so that ends up being 0. All right, let's do one more. Okay. We'll leave that same table. You guys ready for a tough one? See how this goes. Actually, let me change that. Let's make it a negative. A negative 7 minus x. Think about what that minus x is asking you to do. I'll move out of the way, sorry. I'm guessing this first one's going to be a little bit rough. Hopefully. You got it, good job. I thought it's some of you guys. A lot of you guys are doing really well with it. Good job. This one's a tougher one to start off with. Oh, you guys are good. Good job. Good job. I thought that first one would bug you. Good job. Okay, you're good. Careful, the 7's negative. I don't know if you're getting. The first one's okay, but your second and third are not. You're on the right track. You're good. Good job. Good job. Good job, you guys. Holy cow, good work. Good job. Yes, you're on the right track, so you need to keep going. What's that? Yeah. 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 I mean, they come back to me about getting people, and then they give me a hard time about a lot of people writing it. It's always a check that they, I don't know, so they'll be fine, yeah. I'm going to tell them to let staff, like, get kids, you know, like, we need to get back. All right, guys, you guys did really well with this one. I was pleasantly surprised by, because when you go to put the, it's a negative 7 minus a negative 1. So that's become a plus 1. So it's going to be negative 7 plus 1, which is a negative 6. Negative 7 minus 0 is just negative 7. Negative 7 minus 2 is a negative 9. And then negative 7 minus 4 is a negative 11. You guys can clean up boards. We're going to go back to notes here. Actually, I might just keep it rolling. The only thing is, sometimes you don't meet with anyone this morning, right? You can go down and see if they're getting I looked at hers and I was kind of like, I mean, she's kind of like this. Yeah, I know.
It shouldn't be.
No. Okay. So guys, so the next type of problem they're going to ask us to do is they're not going to give us our table this time. They're just going to say to graph it without giving us a table of values. And so we might have to pick some values. Now, I actually don't know how much this happens in tonight's homework. I think it might happen a little bit more in tomorrow's. But just that you guys know that if we have to pick the x values, we can kind of just pick a range of values that make sense for us. But I wouldn't pick values like 52 because that would be way off my graph. So I want to stick like close values that are easy to work with. So what we're doing here now is we're going to pick the x values. Now again, I'm going to tell you guys to pick 5 values. And I'm going to suggest maybe at least picking like a positive, a negative, and a 0 at least. Kind of similar to the ones we did on our whiteboards. So if you kind of like those, we could just maybe stick with those. I mean, just kind of like a range of values there. So if you have the choice of what to pick, it's kind of a good idea to pick, as much as you don't want to, picking a negative number because of the fact that it kind of tells us more about the graph. There's going to be graphs we're eventually going to meet up with that when it gets to the negative, maybe something different happens. So we're going to, again, just like we did before, we're going to find the y values based off the x values we chose. So we're going to put these values in and figure out our y values that go with them. And I think for tonight's homework, you really only have to graph like a couple of them. You have to graph some points, but I think there's only 2 that you actually have to graph from kind of start to finish like this. So I go to put these values in, like the -1. And if it helps to show that, that's fine. I do that just because I know what I'm up to. So -2 minus 3 is a -5. 0 minus 3 is -3. 2 times 2 minus 3, so 4 minus 3 is 1. 8 minus 3 is 5. And then 12 minus 3 is going to be 9. So I got kind of a good assortment of numbers here. Now what we're going to do with that is we're going to plot those points, put those coordinate points on, because those are our x and y values. Remember, x and y moves left and right, or sorry, x moves right and left, and then y moves up and down. And get those values on my graph paper. And hopefully, if we're doing this right, it should form a straight line. If it doesn't form a straight line in what we're doing right now, you've done something wrong. Now, eventually, we'll learn about graphs that don't form a straight line. Now, I don't need you guys to have the most perfect straight lines ever. Obviously, you want to try to draw it straight. If you have a straight edge or something to use, that's great. But when you draw that, you do want to draw the line long and then with arrows. So to show it goes on forever, because this line continues on beyond what our little graph paper has. So straight with arrows. Oops. So as best I can, I'm going to try to draw a straight line through those dots with arrows on the end to show it keeps going. And just getting in the habit of that. I know that sounds like picky, like why do I have to draw a line? Well, because that's technically all the different, anything that shows up on that line, any of the coordinate points it goes through would also work for that line. Now the next two are kind of special cases. So we'll finish up with these last two, these special cases that are kind of strange. So, and maybe like once we go through it, you'll remember that you've learned these at some point, because I know you guys have seen graphing before, obviously because you groaned about it when I mentioned it. But so graphing is something you guys have done before. It's just now maybe it's in a kind of like you're like, oh, I remember doing that now. So typically we get to pick our x values. So let's pick those same x values again. And I just picked those because they're nice numbers to work with. I know they're going to fit on my graph. But this time, you guys, where do I put that in? What happens? Everything is 5. So regardless of what the x is, the y is just 5. So kind of like you keep asking your mom different questions, trying to get her to let you do something. Can I go to so-and-so's house now? Can I go here? No. You just keep getting no, regardless of how you change. Our answer is always 5. So if x is negative 1, y is 5. If x is 0, y is 5. So it's always 5. So when I go to put this on graph paper, what does this end up looking like? It's not exactly randomly placed, because where is it going through? All the 5s, right? It's going to go through all the 5s. So negative 1, 5, 0, 5, 2, 5, 4, 5. So it's just this flat line at 5. We call that type of line a horizontal line. And it has to go up through at 5. All the y values are 5. So when you see an equation that just has a y in it, it automatically, you should think, oh, that's just going to be one of those flat, boring lines. Nothing changes. It's just 5 all the way across, or whatever the number is. So that being said, look at the next one. Any guesses of what's going to happen in the next one? What did you write? Yeah, so do you guys notice the difference in this one? This one, we can't pick whatever x's we want. What is it telling us x always is? Negative 3. So this one's kind of the opposite of what we just did. The x's are all negative 3. So Landon just wrote a bunch of negative 3's down the side. The y doesn't matter in this one. So the y in this case can be anything. So this is the one time where the y value really doesn't matter. The x's are all just negative 3. So just to be super easy, I'm just going to do that. So when x is negative 3, y is 0. When x is negative 3, y is 1. All of these values just kind of boring. And so what does the line look like this time? Straight up and down. We call that a vertical line. So when there's only the one variable, it's either going to be a flat line or a vertical line. And so this is just kind of a way for you guys to start thinking about those types of lines. So the only time they're either flat or vertical is when the other variable is missing. Okay? So what I'm going to get you guys is paper that you can use to graph. Now you can do all of your homework on here. You don't need to put your homework in like a notebook unless you want to. If you're like, I like my homework in the same spot all the time. But I have graph paper for you, and it tells you, you can put all the coordinate points on the one graph, and then the other two are for the graphs where you guys have to make a table of values. So feel free to use this graph paper and your notebook paper, or you can just do your work all over this one. So you don't need to have like a separate sheet. Just don't lose it. And this is posted online in case you got home and you're like, oh, I lost that graph paper and I really want it. If you don't have it at home and you get home tonight, it's fine if you do it on regular paper. It's just kind of hard to make it look nice and it's just on unless you're really good at drawing graphs.
Perfect square.
Yeah, right. Yeah, because that's all everyone's